So this is the world map which is showing the transmission, or it is showing the endemicity of malaria throughout the world. So stable malaria of Plasmodium falciparum predominantly seen in the African region, some parts of India, Bangladesh, Myanmar, Indonesia, Thailand, etc. So Southeast Asia, Africa and Southern America. So we have learnt about the Plasmodium life cycle in our microbiology, isn't it? So Plasmodium species has a very complex life cycle, that it exists in sexual stage and asexual stage. Asexual stage occurs in man and sexual stage occurs in the mosquito. So I will show you the life cycle. So the man gets infected by the bite of a female Anopheles mosquito. So and then once the infected Plasmodium, once the infected mosquito bites, the Plasmodium enters the human system. So it goes into the liver cell. So it starts its life cycle in the hepatic phase. So in the liver cell, the liver cell gets infected to form the next stage called schizons. So these schizons rupture and then they enter the RBC. So it stays intra-erythrocytic and it develops from the schizont to immature trophozoite, mature trophozoite, and then these RBCs also lyse. From mature trophozoite comes the gametocytes. Gametocyte develop into micro and macro gametocytes. So beyond gametocytes there is no development in the human system. So once again when the mosquito takes a blood meal from the human, mosquito will ingest these gametocytes, both micro and macro gametocytes. So this will enter the mosquito and here the fusion occurs resulting in ookinete, oocyst, and then this will further develop into sporozoites. So these sporozoites again it will get into the human system whenever the mosquito bites the human. So there is a sexual stage which happens in the mosquitoes and the asexual stage which occurs in the human body. In the human system we have an erythrocytic cycle and an exoerythrocytic cycle. So exoerythrocytic cycle occurs in the liver. So this is again similarly, yes, so there is a mosquito bite. So once a mosquito has bitten, it injects around 3000 sporozoites. These first go into the liver, that is the hepatic phase or the exoerythrocytic phase. So the schizons develop into the trophozoites. Around 1 to 3 weeks it stays in the liver and then release of the trophozoites then goes into the RBC. It becomes intraerythrocytic, develops into gametocytes, micro and macro gametocytes. When a mosquito bites the human, these gametocytes reach the mosquito. So the fusion occurs. Zygote to ookinete forms the oocyst, then sporozoites. The sporozoites will get settled in the mosquito's salivary gland. So once it injects blood, these so sporozoites will go and infect the human. So this is in short the life cycle of Plasmodium. So main pathogenesis, Plasmodium falciparum is the most severe of all. So the cerebral malaria, severe manifestations are all caused by Plasmodium falciparum. So what is the pathogenesis behind this severity? Okay. So one is as you can see here, these are the RBCs. So some of the RBCs have been infected by the Plasmodium species. So the infected RBCs will all go and adhere to the vascular endothelium. There is this cytoadherence to the vascular endothelium and it results in activation of many inflammatory cells. So because of the cytoadherence and the inflammatory mediators, it results in tissue hypoxia or tissue anoxia. So total obstruction of blood flow happens. So because of the tissue anoxia, it results in anaerobic metabolism. Tissue anoxia leads to hypoglycemia and metabolic acidosis. So this is why Plasmodium falciparum will lead to many severe complications like cerebral malaria, cardiac complications, pulmonary, renal, ischemias, even hepatic failure. Okay. So two important mechanisms you need to understand. One is cytoadherence to the vascular endothelium. Another is the polyclonal activation. So ultimately there is obstruction of blood flow and resulting in tissue anoxia, resulting in severe clinical manifestations. Next, coming to the pathogenesis. So can a person who was infected with one-time malaria, can they get in future? Yes. Future infection or future reinfection is still possible because immunity after infection is incomplete. So there is no complete immunity after infection with Plasmodium. So some of the RBCs which are sickled RBCs, they resist the malarial parasite growth. This is a protective factor against malaria. RBCs which are lacking the Duffy blood group antigen, again it is resistant to Plasmodium vivax. Fetal hemoglobin and ovalocytes are resistant to Plasmodium falciparum. So these are some of the exceptions of malaria. Okay, HBS, Duffy blood group, and HBF and ovalocytes. Some abnormalities in the RBCs will prevent the person from acquiring malaria.